All right, welcome to this lesson on polynomial division. We've just finished doing polynomial operations of adding, subtracting, and multiplying. So now we're going to do polynomial division before continuing on to factoring. So polynomial division is very similar to doing division in algebra and in basic arithmetic. So first we're going to start by doing a monomial division, which is just like factoring out a GCF. This should be a review question for you. We are going to divide out 3p squared TR from this expression here. So that means each term is going to be divided by that. But unlike factoring a GCF, we aren't going to write it outside parentheses because we're actually dividing it away as if we are doing an inverse operation. I like to write it underneath each term. So it's like I'm doing, three little monomial problems. It's just easier for me that way. So when we divide this out, we're going to get 4p to the first because we subtract exponents, t to the first, and then the r's completely cancel, minus 7. The p squareds cancel. Oh, we have an extra little q in here. The t's cancel, and we have r to the first. And then minus 3. P to the first. When we subtract those exponents, and the tr cancel. So I'm just going to rewrite this nicer. Okay, so that's our final answer on that one. All right, but next, what the real goal of this lesson is to get into polynomial long division. All right, so when we divide a polynomial by another polynomial with two or more terms, both the divisor and the dividend must be in standard form with all decreasing powers represented. So if there's a coefficient missing and a power missing, we will insert a 0. When you use the traditional division algorithm, divide, multiply, subtract, and bring down, beginning with the leading term in each. The result can be written as a remainder or as a mixed polynomial, and I will show you what that means when we get to it. So I'm going to give us some room on these, and I'm going to draw a nice line to divide the sections of my paper so that I don't work into the space I need for the other problem. So we are going to do x minus 4 divided into x to the third minus 8x squared plus 4x minus 9. And when we divide, we are going to start by looking at how many times x goes into x to the third. In other words, what do I need to put up here to make this times this equal this? And it's going to be x squared, of course. X squared times x is x to the third. X squared times negative 4 is negative 4x squared. So I divided, I multiplied. Now I'm going to subtract this entire quantity. And to keep from making sign errors, I put the minus sign outside, and then I distribute it through. And it turns it into addition. So these should cancel every single time. I have negative 4x squared, and I bring down my next term. And then I start the process again. What do I need to multiply by x to get negative 4x squared? Well, that would be negative 4x. So negative 4x times x is negative 4x squared. Negative 4x times negative 4 is positive 16x. And I'm going to subtract the entire quantity, which means I'm going to distribute the negative through my parentheses and then add. So these cancel because they're opposites, and 4x minus 16x is negative 12x. I bring down my next term. Okay, so I'm going to need a negative 12 here to multiply by x and get negative 12x. And then negative 12 times negative 4 is positive 48. Subtract the entire quantity. distribute the negative sign through. And it looks like I'm going to get a remainder of negative 57. So I can write my answer two ways. I can write it as x squared minus 4x minus 12, remainder negative 57. Remainder equals negative, however you want to write that. But the way we tend to write it is x squared minus 4x minus 12 minus 57 over x minus 4, the same way you would write a remainder when you were doing arithmetic division. Okay, so that's our first polynomial division problem. Let's look at another one where we have some powers not represented in standard form. So right here, they have written this one a different way with this x to the negative 1. And with exponent rules, we know that means you just move it to the bottom. So it's still a division problem. So we're going to do x squared plus 0x plus 1. I have to have every power represented into x to the 4th plus 12x minus 13. Oh, I skipped some powers. We have a 0x to the 3rd plus 0x squared plus 12x minus 13. All right, now every power is represented in both the dividend and the divisor. All right, and then it's the exact same process we did on the previous problem. I'm going to need an x squared here to multiply by x squared and get x to the 4th. I'm going to need x squared times 0x is going to be 0x to the 3rd. X squared times 1 is going to be 1x squared. I don't know that's plus yet. I was jumping the gun there a little bit. And just double check yourself at every step as I'm doing here in my mind while I'm talking, because you don't want to get to the end and then found you made a mistake in the first step. That's like a little bit of a pain. All right, so now we are going to subtract the entire quantity. I'm distributing the negative sign. Canceling, this gives us nothing, and this gives us negative 1x squared. Okay, so now I need to repeat the process. What do I need in order to multiply and get negative 1x squared? I need a negative 1. Negative 1 times x squared is negative 1x squared. Negative 1 times 0x is 0x. Negative 1 times 1 is negative 1. Okay, I'm going to have to bring down the next two terms here. And then I'm going to subtract the entire quantity. Distributing my negative sign. And I am going to have these cancel. 12x minus no x is 12x. Negative 13 plus 1 is negative 12. Okay, so my answer to this one is x squared minus 1 plus 12x minus 12 over x squared plus 1. All right, so there's some basic polynomial division. Now we are going to talk about another way to do polynomial division, which is called synthetic division. It does not work all the time, or we would teach only synthetic division because it is easier. It works most efficiently when you are dividing by a binomial of just x minus a number or x plus a number. Okay. Now I have a lot of writing here that you could read, but I'm here to explain it for you. And it's very general, so it works for any number. But basically what you do is whatever you're dividing by, like if this is the factor, you know from doing quadratics that the root would be 1. So you put the opposite sign in the box, and then you write the coefficients of what you're dividing into up top. And then it's like a multiply and add situation. Again, you can't have any powers missing on this. So we have a 3, a 2, a 1, and a 0. So everything is represented. So in the box is going to go the number 1, because that is, if x minus 1 is the factor, then 1 is a root. And then I'm going to put the coefficients of what I'm dividing into. If there's a remainder, it's going to end up at the end. All right, so I bring down the first term, and then I multiply. 2 times 1, you multiply what you get times the number in the box, and then you add. It's all adding, because it's like if there's a 0 here. -5 plus 2 is -3. Then I multiply -3 times the 1 and get -3. I add, I multiply, and I actually get a remainder of 0 on this one. And because we are dividing an x to the third by an x to the first, our answer starts with an x squared. So that means our quotient is 2x squared minus 3x plus 2. And if you were to do long division, I will show you, you will get the same answer. Oops. All right, so I would need a 2x squared to multiply and get 2x to the third. 2x squared times minus 1 is minus 2x squared. Then I have to distribute my negative sign. Plus, minus, plus. Here I get -3x squared, and then bring down my plus 5x. See, this -3 here is right there in my work, okay? So now I'm going to need to get my -3x squared, I mean minus 3x. Minus 3x times x is minus 3x squared. Minus 3x times minus 1 is plus 3x. Subtract the quantity. Distribute the minus sign. Canceling, just like these canceled, I have a 2x. Oh, there's my 2. All right, and then I bring down my minus 2. So it looks like I'm going to need a positive 2 up here, because 2 times x is 2x. 2 times -1 is -2. When I subtract the quantity, because they are the same thing, I get 0. I'm not even going to bother distributing the negative. But you can see those numbers come into the same numbers that are here. So you do get the same answer, but it's way quicker. Okay, so that's synthetic division. Now we're going to talk about how to do synthetic division with a non-monic polynomial. In other words, it's not just x minus or x plus something. You have a coefficient in front of your x. I'm going to show you how to do this. I personally prefer to do long division when I don't have a monic polynomial. We call this, I think I wrote up here, it's called a monic polynomial. No, I did not. But something like this where it's x plus r or x minus r is called a monic polynomial. You're not going to be tested on that. Just know it's, when it looks like that, it's the easiest one to do synthetic with. And we're going to use synthetic division a lot throughout the rest of the unit. Okay, polynomial synthetic division with a non-monic polynomial. All right, so when you're dividing p of x, some polynomial, by ax plus b, you set it up in a fraction form and factor out the leading coefficient of a on the bottom. Okay, so what I mean here is I am going to divide this by 2a plus 3, but I'm going to factor out a 2 on the bottom. So that's going to be 2 times a plus 3 halves. Okay, when we do that, now we have a new polynomial we are dividing, which is 10a to the third plus 15a squared minus 2a minus 4 divided by a plus 3 halves. And essentially out front, we have a 1/2 because of that, like a 1 here and the 2 on the bottom. So what we can do, and usually at this point, my honor students are already telling me what we're going to do. I don't even get to tell them. We're going to do this with synthetic and then multiply a 1/2 through our entire answer to make it equivalent. And that is exactly what we are going to do. So if I'm going to do synthetic division on this, I'm going to put my 3 halves in the box, but because it's a plus 3 halves, that means the root is negative 3 halves. I've got my powers 3, 2, 1, none, so I'm going to write my coefficients 10, 15, negative 2, negative 4. And then I start my whole process of multiply and add, multiply and add. So if I do 10 times negative 3 halves, I get negative 15. Well, isn't that nice? That adds up to 0, and 0 times negative 3 halves is 0. This adds up to negative 2. Negative 2 times 3 halves is just 3. So it looks like my remainder is negative 1. Just double checking my arithmetic. Yeah, we look good here. All right. So that means my on the way to the answer is, oops, my pen just decided to die. Okay. I'm not going to start this video over. All right. So we're going to have 10a squared, because it's 1 less power than what we started with, minus 2 minus 1 over a plus 3 halves. All right, now I have to take that entire answer and I have to multiply it by 1/2. So when I do that, a half times 10 is 5. A half times negative 2 is negative 1. And when I take my 1/2 and or my 2 and I run it through the denominator here, I get 2a plus 3, which is the answer you would get if you did long division. So this is the final answer. So this would be a good time for you to stop the video and do the you try it one to make sure you can do it on your own, and then come back and play the video to check your answer. Okay, I'm going to do that one now. Let's switch to a different color. All right, so I'm going to divide both of these by 3. And that means I'm going to have 1/3 times m minus 1/3. That would bring me back to 3m minus 1. So I'm going to take my quotient here. I'm going to actually do this problem with my synthetic division, and then I'm going to multiply it by 1/3 at the end. So in the box goes 1/3, because it's the opposite sign. And I have 2, 1, and none. I'm not missing any powers. 3, 11, 9. Bring down, multiply. 3 times 1/3 is 1. And add. 12 times 1/3 is 4. And add. Remainder of 13. So my answer is 1 less power than what I started with of a 2. So it's going to be 3m plus 12 plus 13 over m minus 1/3. But I have to multiply that entire thing by 1/3. And I'm going to get 1/3 of 3 is 1m 1/3 of 12 plus 13. And then when I run my 3 through the bottom, 3m minus 1. So you may decide you like that better than long division. So you can use it when you have a binomial. You can't use it when you're dividing by something bigger than a power of 2 or than a power of 1 on your denominator, but you can use it if you like it. All right, our last little discussion topic here is what is the significance of synthetic division, especially in this case, the remainder. So we are going to do synthetic division with this to find out what the remainder is, because there is a significance to it. Okay, this will go pretty quickly here. Multiply, add, multiply, add, multiply, add. Okay, great. My remainder is -3. It's going to ruin the rest of my unit because I'm giving away the farm right now. I'm giving away all the revelations, but that's okay. Now we're going to find f of 1, leading us to a discovery here. So that's 2 minus 5 plus 4 minus 4. Well, that cancels out to 0, and 2 minus 5 is -3. Oh, would you look at that? What you get as a remainder is what you would get if you plug it in. They are equal. That is why we call it synthetic substitution. Oops, that was messy. Now, you may say, oh, it was much quicker to substitute than to do, well, somewhat quicker, synthetic division, and you are correct. There are going to be times later when it's really helpful, though. So what I wanted to do is show you that that really is the case here. If I go to a graph of this polynomial, which I have pre-set up in Desmos, the original polynomial right here, I'm going to graph it, and you will see that when you plug in 1, it is -3. Here it is right there. There's the polynomial, and the point 1, -3 is directly on it. Okay, that is the end of this lesson on polynomial division. Please join us for the next one, where we use factoring and learn all kinds of factoring techniques beyond just those for quadratics.